Hello, Flat Earth researchers, debaters, and debunkers. I was sent the link to this website by a Flat Earth debunker in the comments section under one of my videos, and so I thought it would be great to go and have a look at the evidence that is being presented by these globe Earth proponents. So what I'd like to do is look at three particular experiments that have been listed here. There are quite a few. I must admit this website is well put together and it has quite a bit of information, but we'll have a look at some of the rhetoric here that is aimed at flat earthers and also call out the experiments that have been done here for the bad way in which they've done and the assumptions that have been made that we are seeing some kind of evidence of curvature. One of the arguments is that there is a horizon dip. Basically, it's assumed that the higher we go, the lower that we have to look to see the horizon, which is how it would have to be to fit with this idea that we live on a geometric globe. So of course when you draw this in a two-dimensional way, the higher you are from the circle, then the lower you would have to look down to see the surface of the earth in front of you. So this is an argument that's often used. However, it doesn't really equate to what we see in reality. Anyone can check this for themselves anytime, anywhere. It doesn't matter how high you go, even if you go as high as some aircraft might reach 47 or 50,000 feet, and you'll still see a horizon at eye level. The variables, of course, when we are making observations in the real world, very much depend on visibility and other conditions. So we will have a look at the horizon dip measurement from Maine. That's by the Maine surveyor. And then after that, we'll have a look at two of these that claim to show horizontal curvature, or curvature from left to right on the horizon. Namely these two, left to right curve of the horizon from Ibiza and left to right curve of the horizon from Norway. So let's first have a look at this horizon dip measurement, which, if you illustrate a globe as a two-dimensional circle and you use geometry, then yes, it is apparent that the higher an observer is above the surface of that circle, the greater the angle that they would have to look down to actually have a line of sight that meets the surface of a spherical Earth. But again, this is illustrated just as a circle on a piece of paper in two dimensions, basically. So that's the reason for the horizon dip argument, that it has to be that way to have observations fit with us living on a globe. However, anyone can check this for themselves. You don't need a surveyor to tell you that wherever you look, when you have good visibility, you can see the horizon rising up beyond everything in front of you the higher that you get, and that horizon will always be at eye level. That's just how our eyes work. And of course optical instruments work in the same way, such as theodolites and cameras, because they have lenses that are similar to the human eye. So let's just have a look at the arguments that's made here for this horizon dip, which really isn't an argument. It's just something that's come from the globe Earth proponents because of the often quoted fact that the horizon is observably at our eye level. Even when we are in an aircraft that's flying, say, 47 or 50,000 feet, we will still see the horizon at eye level. Our horizon, or the surface, might be clouds, and we can't see the actual surface of the Earth, and it will become quite blurry in the distance. You won't have that sharp-edged horizon when you get very high, because there's so much air, and that's getting denser and denser the farther you can see. However, when you do get down low, we do have what appears to be a very sharp horizon, especially across the surface of water. But anyone who has zoomed in on these sharp horizons will see that there's a point where the surface appears to stop, and beyond that we'll have this mirroring that's going on the surface, and we'll have a band of convergence as well, where basically everything is becoming part of the horizon, and the angle that we resolve this in our eyes is just far too shallow to really see any detail on the surface. When you rise up above a flat surface, what naturally happens is that what was a very condensed horizon then kind of expands like a concertina effect the higher you get above the surface. However, that horizon will always remain in place in our eyes, while everything on the surface becomes more visible because it's not so compressed at the limit of our vision. So this kind of blurb goes on to explain why theodolites are very precise instruments and how they're used for surveying to measure angles both vertically and horizontally. That's fine, no contest there. And it then says here that a very simple task for a theodolite is to measure the angular dip of the horizon. And yes, you could also do that as well. However, what we are dealing with here is an instrument that was never made and is never used conventionally to look at the horizon. The horizon is not used as a reference point in surveying. What's used are tangible objects, and they are never really very far away. One thing we should take into account and take note of is the elevation of just 21.986 meters. So according to this curvature calculator, that would give us a distance that we can see across the surface before the horizon starts to curve away from us of 16.7 kilometers. So let's just go back to that and have a look at the observation that was made. And so we've got this height of just 21 meters above the surface looking across the sea, and we've got this claim that the line is at eye level. I have checked that, and this crosshair is in the center of the image, which was taken obviously with maybe a phone or a camera looking through the theodolite. But what we have here is a couple of things we can discuss or highlight. Is that we just have this claim that the line is at eye level. Now, whether we have any proof that the theodolite is pointing at an angle that's horizontal, completely horizontal, isn't confirmed. We just have the claim here, and considering that we're only supposed to be able to see 16 kilometers across the surface here, we have this absolutely massive gap between the apparent horizon and the crosshairs here. So even if we consider that the truth is being told that this line here, the crosshair of the theodolite, is totally horizontal, in which case you can call it eye level, then what we have here is what appears to be a massive gap. But one thing we can notice about the conditions here is that we see no clouds. We are obviously looking at very hazy conditions, so our view to the horizon will be quite limited, and the fact that we're only 21 meters above the surface means that this horizon line would be like any other horizon line. If we zoomed in, we would see that we have this kind of sharp edge, which is almost a kind of an illusionary horizon, and beyond that we would have the reflective surface going off into the distance and appearing to rise up here. Now, why can't we see that? It's because there are no clouds. The sky and what is being reflected on the surface of the water is all the same color. There are no clouds and there's nothing to help us see if there's any mirroring or refraction or diffraction going on here. So that in itself shows that really we don't have any verifiable scientific proof here of this dip. Now keep in mind again that we've got this massive dip in the horizon being claimed at an elevation of 21.986 meters. And so let's go and have a look at how that compares to some of the other experiments where we have this claim of left to right curvature of the horizon. Now this one, without going through all the blurb, is quite ingenious, I must admit, and we are invited to download these photographs and have a look. The first one we have here is just a photograph of the setup, which is a table with two kind of spirit level things on this table, and then this is supposed to act as a horizontal line with which we can compare the horizon in the distance. And then here we have a close-up where the photographer has done quite a good job of getting everything lined up in the center, so they have pretty much a horizontal view that's at the same eye level pretty much as the spirit levels here, and of course we can see the horizon here in the distance. So this is one thing the first observation we can make, or the first comparison we can make here, is that this was done at a height of, I believe, somewhere in the region of 500 meters. I'm just going to look for the number here. Where is it? I think it might be down here. So, yes. So what we have is an elevation of 603 feet. And we see, and I'll show you in a second in another program, that this horizon is pretty much at eye level. So that's at 603 feet compared to this by the main surveyor, who claims to see this massive dip in the horizon during hazy conditions at only 21 meters, a lot less than the 600 feet that we are looking at in this one. So this image itself already debunks the main surveyor's claim that we've got this massive horizon dip, because here on an experiment aimed at observing left to right curvature, we have a horizon that's at eye level at 603 feet. By opening up the photograph in image software such as GIMP here, we can verify that the horizon is indeed at the observer's eye level, even though they are at a much greater height of more than 600 feet compared to the 21 meters that we saw the photograph of a horizon by the main surveyor through a theodolite. Also, we can see here that the conditions are a lot clearer. The sky is blue here and we can see the clouds, whereas we couldn't see any definition like that in the photograph through the theodolite, with the claim that the horizon was dipping. So we can check also that the horizon is at eye level simply by looking at the size of the image here and then finding the halfway point. So we can see that it's 4032 pixels across and it's 3024 pixels from top to bottom. That gives us a halfway point of 1512 pixels. So you can see down the bottom here, the numbers will appear down here, and as I bring this guide down to the center, we've got 1516. Okay, so in this case, with this line right across the exact center of the photograph, we can confirm that the photographer has done a pretty good job of pointing the camera directly ahead, 90 degrees to plumb, and they have these levels on the table pretty much at eye level. And of course, you also have the horizon in the background at eye level, which again confirms that the horizon does in fact rise to eye level. And this is at an elevation of 600 feet, much higher than the elevation of 21 meters or so shown to us by the main surveyor through a theodolite, and claiming a massive dip in the horizon. So it's funny, isn't it, really? This photograph itself, even though they're trying to point out evidence of left and right curvature, they've actually proven that the horizon does rise to eye level and there is no horizon dip as claimed by another experiment. So now we have to check the accuracy of this photograph and where these claims have come from that the horizon is somehow bending. So if we go back to the web page with these photographs on, we can see down here that what they've done is compressed the photograph to reveal this apparent bulging and bending of the watery horizon behind these levels here. It says here that there are some techniques to make the left to right curve easier to visualize other than zooming and panning. For example, if we simply compress the image horizontally, we are able to see the curve much easier. This is not any sort of manipulation technique, it just allows the entire zoomed in photograph to be compared in one image. Here is the photo with straight edges cropped and horizontally compressed. So they have manipulated the photograph. But one thing we have to check here is what kind of camera or lens was used to take this photograph. Turns out from the EXIF data from this photograph that the camera was an iPhone SE. And one problem that all photographers face with even the most expensive equipment is barrel distortion. And of course it is especially a problem with the wide angle lenses used in iPhones. So there's lots of software you can get to fix this, because obviously they know that barrel distortion occurs in iPhones, and you have to find a way to fix it if you want to make it look more real or get rid of that barrel distortion. So, and I don't need to read this, anyone can go and look up barrel distortion themselves and find out that it's a problem for all kinds of photography. So that's number one there. We've got this image taken on an iPhone that's not necessarily a professional camera, that would definitely have barrel distortion. But the main point of the setup of this experiment was to use the straight and hopefully correctly aligned edges of the red metal bars and compare those to the horizon. So on the left we do seem to have this apparent drop where we see more sky and less water here, and what appears to be a distinct curve. So apart from barrel distortion, is there anything else that we can look at to see if it could be another contributing factor to this misalignment of the metal and the horizon? So I've gone back to this photograph here. I've got three guidelines put in place here. The middle one is the first one I put in, which is the dead center of the photograph, the eye level. And we have one at the top, which is kind of pretty much aligned with the top of the piece of metal there, and one that's aligned with the bottom there. So let's just zoom in on the right hand side to start with, because that's where it was looking kind of level to start with before it curves away. So we can see this top guideline is pretty much snug with the top right edge of the bar there, but not quite aligned up there. And the middle one is pretty much in the middle of those two, a little bit below the gap between the two bars as where they're joined. And this lower guideline is also fairly snug with the bottom edge of the right hand side piece of metal, and fairly snug here with the lower piece. No, actually, there's there's a gap there between the lower piece of metal and this guide. So remember, these guides are perfectly horizontal, so they are as good a guide as any for checking whether everything's level. So here we have an immediate disparity where on the left hand side this horizontal guide is no longer snug with the top left hand end of the metal. So obviously this is not in line with its counterpart on the right, which is snug with the top guide. So just again take note of the lower guide there and see where it is, and when we come over here we can see there's a slight difference here, and also this middle guide has come up and away from this lower piece of metal here, and we can see that on the other side it was fairly snug with that lower piece of metal. So basically we have a couple of issues that have occurred here. Obviously these pieces of metal, which were supposed to be the level reference against which the horizon is to be measured, are not level, are not straight. This could be because they are not physically aligned, or it could be a result of the camera not being totally aligned with the apparatus, or totally square to the apparatus. So unfortunately the very setup of this experiment and the way it was supposed to verify whether there's curve has just resulted in showing that it wasn't a perfect setup to start with. And when you're dealing with what comes across as a few pixels on a photograph, and then you've got this massive gap here, then it's all gone a bit skew-whiff. So unfortunately that just has really kind of debunked itself, just because the experiment wasn't set up properly, and at the same time it has helped show that the horizon is at eye level. And if we briefly take a look at this other photograph showing the setup from a greater distance, and we put a guideline here on the horizon, remembering that the photograph used as evidence of curvature had the curve apparently going down to the left, but in this case with this photograph we've got it quite snug here on the left, and then the horizon goes down and away from the guideline on the right. So it's really just a case of the challenges you face when trying to line up an iPhone perfectly and make sure that it's level horizontally, vertically, and it's not tilting in any direction, as well as the apparatus itself. So it was a good attempt, but it just shows that there were some discrepancies in the observation made and the experiment setup that really do show that if you actually did align everything up properly, you would have a very flat horizon in between those two pieces of metal that are supposed to be level but unfortunately are not, either because they're not physically level or because of the angle of the camera making a slight difference to the whole scene. With perspective, obviously the horizon's further away, so it would, its relationship to whatever's in front changes with any minuscule movement or tilting or misalignment. So good effort, but unfortunately that's debunked. So let's go and have a look at the third one, which was another example of left to right curve. This was taken in Norway, I think, and so I've downloaded the image. It's not quite as large as they say it is here, and it's quite interesting. This person who's studied this has gone to great pains to even create this image here by counting the pixels of difference between the edge here, what's supposed to be a straight edge, and the horizon. So we've got on the left hand side we've got 32 pixels, then 33, 34 and 35. So we would appear to have this difference in the gap between the straight edge here and the horizon. So it's assumed that the horizon is curving. Well, let's go and have a look at the photograph itself. And again, we can do our very simple thing of well, in this case, we don't even have to find the middle. What we'll do is we'll line up the guide with the piece of wood that was set to be level or straight. So let's see what we find here. Let's have a look at the left. Well, we can see a gap there. And now on the right, okay, in the middle there it comes snug with this guideline, and over here, no, it's not. So again, what we're possibly looking at is one or two things. We've got a piece of wood that isn't straight and isn't level. All right. We've also got possibly the camera not being flush or square, looking at the whole apparatus straight on. Again, this will make a difference to perspective, because if that's the case, where the photographer is looking at an angle other than straight on, then of course what we have is this perspective is the, one end will be further away from the observer than the other end. So that appears to be a problem there. But basically you can see that if you're, whatever you're using to say is straight and level isn't straight and level, then it's a void experiment. It would be interesting to see what we do if we actually put a guideline across the horizon there, and yeah, we kind of can't do that because obviously the camera has really been tilted. It's just not looking at this whole scene properly. So to be honest, this is a very unscientific attempt, and of course that's why in the image just now with the pixels you have this gap increasing or decreasing, whichever way you go, because this whole thing isn't lined up, in fact. Okay, so here's that screenshot, and again we'll check whether it's level. So no, I mean the person counting the pixels wasted a lot of time without first checking whether this was horizontal. Yeah, so of course you're going to get a difference in pixels if the level you're using isn't level and straight. Just to be clear, what I'm showing you here, I've put a yellow line across this horizontal guideline, and on the left we can see that it's quite flush with the top of the piece of wood that we've used in the photograph, but on the right we've got a gap. So either the wood itself that was used as a level reference is not level, it's actually tilted, or we have the camera not completely square or flush with the piece of wood, which then creates this difference in the perspective, or it could be a bit of both. The point is that what is used as a level reference is not level, and then that is mistakenly used to be interpreted as curvature, when really we can see that actually this shows us that the horizon is indeed flat, the horizon is indeed at eye level, and the photographs and experiments that have been done so far to somehow say they can prove that there's curvature don't. They prove the opposite. They prove that there is no curvature. So what is it? Is it sloppiness? Is it an inability to be truly scientific and study and scrutinize all the variables and make sure they do everything accurately? Or is it something more malicious and deliberately misleading? Well, I like to give people the benefit of the doubt, and people, we all make mistakes, and that's how we learn and grow. However, when you look at the rhetoric that we are presented with on these pages, then it's obviously more deceptive, deliberately so, than trying to be truly scientific, especially when we come down and we see the kind of rhetoric here. It says, feel free to download the original photograph and do your own compression. Better yet, count the pixels from the straight edge to the horizon and plot on a graph. Well, it wasn't a straight edge, was it? So there's a false claim there, a misleading and deceptive claim there. But then it goes on to say, of course, no flat earther will accept this. It violates their pre-selected outcome. No, not at all. None of us came along assuming or wanting the earth to be not a globe. We all believed that we lived on a globe until we actually looked and we put aside our beliefs and then checked to see what we could or could not confirm. So there is no pre-selected outcome. The outcome is obvious when you actually look and be scientific about it. However, this person goes on to say, they will claim they don't see the curve, attempt to change the subject, start calling names, run away, make accusations of tampering. Never will a flat earther be honest and face this photograph. Well, we've just faced several of the photographs and shown how they, in fact, prove things such as the horizon is at eye level, because that's what flat surfaces do when we look across them. And we've shown that these photographs are not done in a scientific way and have been deceptive rather than being truly scientific. And he finishes up by saying, remember, the ultimate victory is when a flat earther blocks you. That's how they concede defeat. Again, this is so full of misunderstanding about the whole thing here. It's not a contest. It's not about who's winning or losing. Although it's often talked about as being a debate, and I even welcome debaters on my channel. Actually, I'm happy to let people come along, and if someone can actually give me measurable proof of curvature on the surface of the Earth without any other explanation that's truly verifiable scientifically, then I will accept it. But so far, all we see is either ignorance or an inability to make those kind of comparisons, such as the photograph we saw from the main surveyor saying there's a massive horizon dip at 21 meters, whereas at 600 meters there isn't a dip. In fact, you actually lined everything up with the horizon. So why can't you see the contradictions in those kinds of arguments where there either is or there isn't a dip at the horizon? Or, you know, it just goes on. The contradictions are abound, and that's what leads us so-called flat earthers to realize we're not on a spinning ball, because all anyone ever has is stories. And this idea that it's something to be won or lost is wrong, because really the battle is within. You have to really scrutinize your beliefs and be pragmatic about the whole thing and really study reality rather than relying on stories that have been made up to go along with a heliocentric model. So you can obviously come back to this site and look yourself, but I think I've done enough work on disproving at least 3 of the so-called proofs that they've come up with here about the horizon not being curved and apparently, you know, not dipping either. Thank you very much.